Hello, and welcome back to the Baylor University Physics Tutoring videos. Today we'll be discussing sinusoidal harmonic oscillators. So the first thing that we need to address is period. Period is the time it takes for something to complete one cycle. So when talking about sinusoidal harmonic oscillators, also known as SHOs, what we will be doing for our period is this equation, where period is equal to 2 pi times the square root of mass over the spring constant. Notice that amplitude is not in this equation. The amplitude of the object does not change its period. Alrighty, so what are we looking at here? Well, what we'll be seeing is something along the lines of this. What we have is a box on a spring vertically. And so if we pull this box down or push it up, we'll see it go up and down, over and over. And if we were to graph this vertical displacement with respect to time, we would see a sine or cosine graph that's very similar to something like this. And so what we have here is we have our periods on the graph. And this gives us some fun things to do. First, we can have this position equation, where our position is equal to our amplitude times our cosine of 2 pi time over period. And so that will give us the position at any point, granted that we know the amplitude, the time, and the period. What we can do from that now that we know that these are sinusoidal graphs is we can take their derivatives. We know that velocity is the derivative of position. So our velocity equation is our negative v max, our maximum velocity, times the sine of 2 pi time over period. And then if we need to find our v max, we know that that is our amplitude times the square root of our spring constant over our mass. And so our v max is going to be at the times where we have right here an equilibrium. Whenever we're at our maximum amplitudes, we're at 0, but whenever we're in equilibrium, we're going to be at our maximum velocity. And you can kind of see that on this position graph, where the times that we're at the times that we're at our equilibrium point are the times that we have our highest velocity, and the times that we're at our amplitude, maximum amplitude points, there is no velocity here, if you kind of look at that derivative. And then going off of that, we know that acceleration is the double derivative of position, or the derivative of velocity. And so we know that our acceleration is going to be equal to the negative acceleration max cosine of 2 pi time over period. You can see this cosine, sine, cosine derivative relationship. And then our acceleration max is k, which is our spring constant, times our amplitude over our mass. And we can see the same thing here, where these are going to be the points of our highest acceleration, and these are going to be the points of our lowest acceleration. Alrighty, thank you very much for watching.
I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter what physics class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you're a currently enrolled Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need about these services on our website at www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online, or just drop in during any of our open business hours. For more information about our current services, please visit our website. Thank you.